Hi students. So I'm going to be going through this Mechanics Worksheet 2, Unit 2. I'll go through it in sections in a number of different videos and hopefully you'll find it useful. If you have any further questions, please come and see me and I can give further explanation. So in the first one over here, it says a net force of magnitude F acts on a body. Define the impulse of the force. Now we know the impulse is defined as the force acting on times the time for which the force acts. It's also equal to the impulse, if I use I, is equal to the change in momentum. Change in momentum. So it doesn't matter how you define it, as long as you define it either in terms of change in momentum or force times the time acting on a body. In the second question over here, it says a ball of mass 0.05 kilograms is traveling at a horizontal velocity of 2.2 meters per second. It strikes a vertical wall and rebounds horizontally. So we got that. Due to the collision of the wall, 20% of the ball's initial kinetic energy is dissipated. Show that the ball rebounds from the wall with a speed of 1.97 meters per second. Well, the first thing that we've got to do is we've got to work out the initial kinetic energy. So the initial EK, which is equal to a half mv squared. So it's a half times 0.075 times 2.2 squared. We can calculate that. So I'll just do it on my calculator here. So it's 0.5 times by 0.075 times by 2.2 squared, and we get 0.182 joules. Now 20% was lost, so the energy, the kinetic energy of the rebounding ball will be that value times by, so let me call this EK 2 and I'll call that EK1. So rebounding would actually be equal to 0.8 times by this 0.182. Please excuse my writing. I'm writing on this pad, which I'm not very good at. So it's 0.182. So 0.182 times by 0.8. So you've got there is equal to 0.1456 joules. Now that's a kinetic energy of the rebound. So we can work out the velocity of that by putting that 0.1456 is equal to a half times the mass 0.075 times by the new v squared. So I'm going to times that by 2, that original value equals, and I'm going to divide by 0.075, and I get my value of that, and then I take the square root of my answer and I get a value for v of 1.97 meters per second. Now it then says show that the impulse given to the ball by the wall is 0.313. Now remember that the impulse, your F times your change in t, is equal to the change in momentum. So that is m, your final, minus your initial. Now what's important here is that we remember that because we're going in a reverse direction, I'm going to make this the positive direction, the reverse, and therefore this would actually be a negative. So we're going to have there is equal to 0.075 times we're going to have our final is 1.97 minus 2.2. As long as you choose a direction to be positive, then the other one will be negative. And so if I multiply that out, plus, I'm just going to work this out, 2.2 equals times by 0.075, put that in my calculator, and I get 0.313 newtons per second, Newton seconds, because it's a force times the time. Alright, so that's that part of the question. I hope you understood that. I'm going to have to get rid of that all, so hopefully you got that. And then we'll go on to the next question, which is over the page. This one over here. So it says the ball strikes the wall at time t is equal to 0 and leaves the wall at time t is equal to t. The sketch graph shows how the force that the wall exerts on the ball is assumed to vary with time. And we're told here that the time that it's in place is 0.0894 seconds. So using the impulse given in B2, that was the impulse there was 0.313 newtons seconds. We know that's equal to our force times our time. That's equal to the impulse. Now, this area here, this area would actually be a force times the time amount. So this is actually going to give me an impulse amount. So if I work that out, then that value over there is my F maximum. Sorry, this is my child coming in, making the noise. That's going to be the force maximum. So my force maximum, my force F max times the time, which is 0.0894, and to do this we are going to times it by half, because it is because it's a triangle, and the area of a triangle is the length of the base times the height, and when we work this all out, we get our force maximum works out to be 7 newtons. Now that's the maximum. Now because we're going from 0 to the maximum, and this is a straight line, we can get our force average. Average would equal your start plus your final divided by 2, so that would equal 3.5 newtons. Alright, so that's that question. I think I'm going to leave it there for the moment, and then I will do another video for the next question. Thank you very much.